All right, our next example is a survey of 114 cats. Suppose we're doing research in a kennel. A survey of 114 cats found that 63 have a particular genetic marker. Use these data to construct a 95% confidence interval for the proportion of all cats with the genetic marker. And so, that's our task. We need to construct a 95% confidence interval for the proportion of all cats. We're going to, again, use the sample information to estimate the population information. That's why we say this is a confidence interval for the population proportion. We have a confidence interval for a population value. This is always the value we're trying to estimate. We use the sample information to estimate this. Even though this number doesn't appear in the formulas, this is the entire reason the formula exists, is because we want to estimate this value. So it's a confidence interval for the population proportion. Earlier we did confidence interval for the population mean. That means that we're trying to estimate the population mean using the sample mean. Here we're trying to estimate the population proportion using the sample proportion. The formula is on your formula sheet. You don't need to have that memorized. So I'll just throw it down here. P hat plus or minus z subscript alpha over 2. Then we have this big square root. It's p hat times q hat all over n. All right, so we need to compute our values. First, what are we given? 114, what's that? That's the sample size or the number of trials. That's n. 63, that's the number of successes. So we're evidently in this problem, we're defining success has the genetic marker. So the number of successes is 63. From that, we can compute p hat, which is x over n, which is 63 over 114. And I'm going to compute that, 63 divided by 114. I have 0.5526. I'm going to round that to 0.553 and be unapologetic in using this rounded value. And then from that, we can compute q hat, which is 1 minus p hat, 1 minus 0.553, and that gives us 0.447. All right? So we have that number, we have that number, we have that number. That number was given. We still need to find z alpha over 2. Again, that comes from our special table that we had, right? Special table. And the 95% confidence level, we want the 1.96. So the z-score, 1.96. The rest of this is plug and chug, should be very straightforward. So substitute the values. We need p hat, which is 0.553, plus or minus z alpha over 2, 1.96. And then we need the square root, 0.553. Q is 0.447. Square root of n was 114. And then we start mashing buttons on our machine. I'm going to show my work. And I am unapologetically using these rounded values now. So I have 0.553 times 0.447. Divide that by 114. And then take the square root of that number. And I have 0.0465, I'll say 0.0466. Again, this has been rounded. This has been rounded. This is just chock full of round-off error, but it's sufficient for our cause. And then multiply that time. So I'm going to clear and actually use these numbers. I'm not going to use the official numbers. I'm going to clear and use these numbers for so we're all using the same numbers here. 0.0466 my grammar is nice here. 0.091. So again, approximately that's 55% plus or minus 9%. But for our purposes, that is sufficient. All right? And so we'll do maybe a couple more of these, and then that should, I hope, give you enough practice so that you should be able to handle anything that gets thrown at you.